Hello, everyone. Welcome to the talk. I'm going to present deep interpretable criminal charge prediction and algorithmic bias today. And my name is Jia Xu. This is a joint work with Abdul, Peter, and Rashid. The crime rate is a critical issue in the US. For example, this is a picture of reported crime incidents per 1,000 people in 2014. We can see in certain locations, there is really a very high number of criminal rates. And globally, we can see that more than 400,000 people die from a homicide each year. This is 1 to 10% of the global deaths. So since machine learning has been used in so many places, for example, Netflix, weather forecasting, computer writing, and speech recognition and games, can we use machine learning to help this very important issue? Now, in this work, we're going to study criminal charge prediction. Criminal charge is a formal accusation made by the governmental authorities. And this means that it's assert that somebody has committed a crime. And how can we use machine learning to do a better criminal charge prediction? So first of all, the criminal charge can be classified in 3 different categories. There are different level of severity. So the level 1, which is most severe one, is a felonies. This include terrorism, murder, kidnapping, and so on. The level 2, which is the middle severe one, is misdemeanors, which include threat, bribery, and so on. The least severe one is infractions, for example, damage the property, burglary, and so on. Now, what our data set that we want to work on is the criminal charge record from individuals from 1997 to 2015 from New York Police Office. So we split the whole data set into 2 parts. The first 18 years of each person in the entry, they consider to be the training set, and the test set is the last 2 years, which is 2016 and 2017. So we can see this one example of the bookings. We have the ID of the person, number of the level 1, 2, 3, time span, and so on. So these are all our features. Those features basically are in 2 categories. One is the previous booking history, whether this person has committed a crime in the past 18 years or not, and if yes, when and what is the level, and so on. And the other feature is kind of personal information. This includes 3 major information. One is the gender, the other is race, age, and the last one is a race. So we want to study whether this gender, age, race are going to be important in predicting the criminal charge in future. Now we can see in order to have a better prediction, the data need to be more smooth. So our data is highly imbalanced. That means the positive samples are much, much less than the negative samples. We're going to talk about it later as our challenge. So to define our questions, we propose 4 different tasks. So given a person's information and previous records, basically everything in the previous years, for the next 2 years, can you predict whether this person is going to commit a crime at any level? Once you know everything he did before and his some personal information. And the other question is whether this person is going to be committing a crime of level 1 or 2 or 3. So these are 4 different questions. We're going to build 4 different models basically 4 different systems in order to predict them. So using machine learning, we're going to put all these important features into the prediction. So these features are what we presented before, like booking rates, current age, number of bookings, and so on. So what we have as information in the previous years. And the class is basically this question answer. So whether this person is going to commit a crime at level X or not. So basically for each of the question, we have a binary classification task. And now to the learner, we're going to find some model for the learning. And in this case, of course, we can use the neural network to do the prediction. And after that, we build the classifier and learn the parameters, we can do the prediction. And this is the way we use machine learning to do the crime prediction. And from the starting point, we consider the fully connected neural networks. In that case, we have actually a high prediction accuracy we won't discuss about later. However, this is not the real accuracy. Why? Because we mentioned that we have a lot of negative samples. So the classifier tends to classify everything as negative so that it reaches very high precision. And in that case, we can see no true value was considered to be positive. And this is not the right classification. And therefore, this numbers does not indicate the real accuracy. In this case, a simple example in this binary classification with the hyperplane, we can just lose the accuracy from the double plus and gain the precision. However, it means we didn't predict anything because everything will be considered to be negative. And to solve this challenge of imbalanced data problem that causes a low F1 score, basically no low recall, we consider some information from the data we receive. So in this case, what have missed? We'll probably have missed some patterns. If we put the personal crime behavior along the time span, then we can see that those patterns may be repetitive, not only for one person, but also occur shared among different persons. In this case, for example, Zhou Dong has committed a smuggling in 1995, 1997, and later on he did the level 2, which is the 2000. And after that, he repeated the same thing again. And we probably can consider this is a pattern. Now it's pattern level 1 to level 2. And later one, we have a level 1 to level 2 again, in this case. And after that, we have a level 2 to level 2. And can we use these patterns also, not only for one person, but also for everyone to do the better prediction? Now, in order to do the sequence learning, we can consider this as a ball going through the temporal events. And we want to, based on how the ball goes right now, we want to predict how the ball is going to go future. For example, it can go up, it can go in the same level, and later on, maybe it go up again. Then you can predict a crime level now. So this is a temporal sequence prediction, and we are using the recurrent neural network to model such a sequence event, where each state is basically 1 year of the ticket entry, and we can learn by sample, and each person is one input. And in that case, we can learn the pattern of the personal behavior along the temporal. And since this is 20 years, it may have a vanishing grading problem. That means long distancing will not be important anymore, but sometimes we may consider it still. So we have introduced bias TM to further improve the result so that it's more accurate predicted. Finally, to further boost the accuracy, you can also consider the attention mechanism to learn the important features. Maybe level 2 is more useful for level 3 or level 2 prediction and so on. We're going to discuss later. Now, after adding the attentional model, we can use the attention to learn the feature weights also. Now, first look at the prediction accuracy. We basically increase the F1 everywhere, and by increasing the recall number, so LSTM gives a very nice result, similar to that bias TM with attention mechanism gives even better and consistent improvement. And the second challenge is the interpretability for trustful prediction. Now, the feature importance, we can use the attention mechanism that is learned from the model to mark whether this is important feature or not important feature. So if the attentional weight is high, that means this feature is used more by predicting the final result. Otherwise, this feature is not very useful and you should basically can exclude it. Now, surprisingly, we find out that the race, age, and so on, this personal information is not much helpful for our final result prediction. Therefore, basically, you can always exclude it from your algorithm prediction. And most important, it shows a model design by itself that these are not important features. And on the contrary, important features are the previous criminal record. For example, level 1, level 2, level 3 record and its average, and also some number inferred from that. For example, the variance of the time gap from one ticket to another ticket. And also the mean time gap, how often you are doing this. Now, this analysis shows us that the criminal histories are the statistically significant factors for the algorithmic decision. And basically the algorithm itself does not explicitly introduce bias because these personal identifiers, even you include them, is not going to be used based on your learning algorithm because your learning algorithm suggests race, gender, and age are not helpful for the decision and may have very low weight. Also, when we exclude them, we're going to have almost similar prediction accuracy. Also, the F-score. So these personal identification are not used. Of course, there may be a chance that the data itself contains bias. This is out of scope of the paper. Now, another thing that we're interested in is whether there is a transition from different levels. So, for example, one person committed a crime, level 2, whether it's more likely to increase the level of the crime, or this person is going to stay in the same level, and so on. So we consider two measurements. One is correlation, and the other is causality. And causality means the feature importance. So that means when we predict level 1, in this case, what is the feature importance learned from attention model of level 1, 2, and 3 to predict level 1. And correlation means the probability of level 1 given any of those levels. Now we can see that when we want to predict, for example, level 1 is level 1 itself, and also level 2 are actually important features. Similar for level 2, when level 2 appears, level 1 and 3 are both important features. And finally, for level 3, we can see that level 3 itself is very important for itself, and also level 2 is also important. Now, we can see that the suspect is more likely to commit a crime with the similar level, and again and again, or something more high, a little bit higher, then switch here higher or lower, and so on. So as a summary, we have used deep learning for the criminal charge prediction, and we had two challenges. One is low F1, and the other one is interpretability. For this, we have introduced the BIOS TM to model the temporal patterns of individual behaviors, and we have used the attention mechanisms to learn some post hoc interpretability. And well, what we learned from the social aspect is that the criminal charge histories are more essential features than the social features such as race, gender, and age. And also a suspect that has kind of a graduate transition of his personal behavior in the criminal case. And this is giving certain insight of crime prediction by preventing the crime from a low level in the beginning, so that this person does not gradually develop some severe crime. Okay, thank you.